Just had to make sure that it was on. All right, so today is day 2 of Unit 4, talking about cell transport. Today we're going to specifically talk about osmosis. And I'm going to show you some example questions that I'm going to be giving you on it um, so that you can kind of see the types of things that would be asked from here, other than just some of the basic vocabulary type information, some of that little bit deeper understanding. All right, so osmosis. First things first, we need to know that osmosis is the movement of water across the membrane. That's the same thing from our yesterday's information, day one's information. Now, we do need to make sure that we know that whenever we're talking about this, we're going to have a few key terms here. We were talking about hypertonic solutions, hypotonic solutions, and isotonic solutions. A hypertonic solution is basically what we're going to be looking at here is we're going to be talking about a cell or an osmotic bag or some type of tubing that has a selectively permeable membrane, so basically like a cell membrane, and we're going to be putting it in different types of solutions. So whenever we take a cell or something that has a permeable membrane and we put it inside of a hypertonic solution, the cell is going to shrink or shrivel. It's going to get smaller. And the reason why is because water is moving out of the cell or out of the bag or whatever it is that we suspend in the solution. If we put it in a hypotonic solution, that's going to cause the cell to swell. Now, it could cause it to swell so much to where it bursts. You'd also see the term like lysis here. That's Lyses, I think. Because water is moving into the cell. If so much of it moves into it, then it'll burst. And then lastly, we have an isotonic solution. This basically is whenever we put a cell into an isotonic solution, that means that it has a balanced gradient. Whenever we say gradient, that's whenever we're talking about what was going on in that concentration gradient on day 1, where the rock was on top of the hill and it could roll freely down to the bottom. But imagine if there was no hill, it was just flat land, the rock isn't going to move at all because it's just nice and balanced. This does not mean there's this causes no net movement. Now, the reason why I put in parentheses here is equal movement is students in the past have gotten the impression that no net movement meant no movement because they didn't understand the word net. Whenever we use the term net movement, what is the net movement? That means that if we were in class and 3 people came into the class, and that means that the class went, let's say originally there was 20 people in there, 3 people came in, then that means that it increased by 3. But if 3 other students that were inside the class also left the class, then that means that the total number of students in the class or the total number of people in the class is still 20. That would be no net movement there. That means that I didn't gain anybody or didn't really lose anybody. It just stayed the same. Okay? So that's why we call it equal movement. If one comes in, one goes out. So if some water comes in, the same amount of water is going to be leaving out to keep it balanced. So I have some images to kind of go over each one. So right here, what we see in a hypertonic solution, so we're going to say that this, where it has the 10% salt and this like brown circular-ish looking thing going around it, we're going to say that that's the cell. So if we have 10% salt inside the cell and we have 20% salt outside the cell, well, what we have to remember is that we're talking about water moving here. That means the inside has 90% water and the outside has 80%. Well, 90 is a higher number than 80. So that's why the water would move from the inside of the cell to the outside of the cell. And that's why the arrow is pointing that way. So water would move out of the cell, causing this to be a hypertonic solution. Okay, and one thing that you're going to be getting, this is actually a type of question that you would be getting. So imagine basically if I don't put the arrow there on this image, and I also take off where it says the answer, water moves out of the cell, and I'm just asking you, which direction would this arrow be pointing? Or what is happening to the water here? There you go. That's the type of question that you could be seeing there, is basically me giving you an image and asking you to explain exactly what I just did. Okay. Now, sometimes I make it really easy for you because I'll also go ahead and tell you in the prompt or even on the image, I might go ahead and put on there water and what the water percentages are. But just make sure that you know that if it's asking about the, the tonic solution, you need to make sure you find the amount of water because that's what we're looking at in passive transport and osmosis is the movement of water. So here's one about hypotonic. So basically all I did here is just switch the numbers around. So now we have 20% salt inside the cell. Well, that would be 80% water. And we have 10% salt outside the cell. Well, that's 90% water. Well, it still moves from high to low concentration from 90% from the outside into the cell to where it's only 80% water. Okay, and that would be hypotonic. A lot of people like to think about hypo as hippo because it's getting bigger, like a hippopotamus, hippo getting bigger. And last one is isotonic. So basically, 10% salt, 10% salt. That means 90 and 90% water. Well, that means that that's why it has the double arrow here. Some water's going in, some water's going out, but it's going to be the same amount. That's that equilibrium. You'll also see that term instead of balanced, equilibrium because it's equal movement. All right, so this is something that I have y'all do during class, and we'll get into that. Basically, with these, this is basically the steps that I have for you in solving these questions that you're about to have. Um, it'll kind of help you, especially if you kind of struggle with figuring out which one's the 80% or which one's the water and things like that. I really think these steps will help you in identifying it. If you know that your first step is to always draw the cell, write down the percent of info, whatever info I give you in the cell, draw a jar, put the cell in that jar, write down what I give you about it, and then make sure that you always convert it to water. Now, if I give you water, you don't have to worry about it. But if I don't give you water, you need to convert it to water. All you do is subtract it from 100 because we're talking about 100%. And then you just draw an arrow from the high water percentage to the low water percentage. So this is just steps for solving the question. If you want to write these down or save this right here so that you can use it and reference back to it while you're looking over these practice questions, go ahead. So here's practice question 1. I'm going to have all the answers for these at the end. I think I have 4 practice questions. So pause it. You'll be able to see it at the end. So I'm going to go ahead and move on, and you can just pause it and answer your questions. All right. So this is practice question 2. Again, pause it, write down your answers. You'll see the answers at the end. All right, I'm about to move on. Practice question 3. Now this one actually has 3 different answers. I'm wanting you to figure out, the red blood cell stays the same at 0.9% sodium chloride, that's salt concentration. And I'm wanting you to put this red blood cell in flask X with this amount, with 0.5% sodium chloride, in flask Y and in flask Z, and tell me what would happen to the red blood cells that are placed in each one of them. All right, so there will be 3 answers there. Go ahead and work that out. Moving on. All right, same thing as that other one. You'll have 3 answers here as well. What I'm wanting you to know on the first one is basically just tell me which way is which way is the water moving for each one of these. And you don't have to use an arrow. You can just say in or out or equal. I think that's what I did. All right, moving on to the answers. So here are the answers for that. And this is what I meant on number 3 about how X would be flask X, Y would be flask Y, and Z would be flask Z. And number 4, those are the different answers there that are in parentheses there. Okay? So here's the review from osmosis. So make sure that you're able to explain what is meant by the concentration gradient and passive transport. That actually goes back to day 1 stuff. The reason why that's such an important question is that you're going to be seeing a lot of information that deals with your ability to understand what that means by concentration gradient. So please reference that back. What are the 3 types of solutions? That's the 3 that we just went over with the hypertonic, hypotonic, and isotonic solutions. Make sure you're able to understand what's happening to the cell in each one and why is that happening. So if a cell is placed in a highly concentrated solution, which way would the water move? If it's highly concentrated, that means it's highly concentrated with a solute. That means it has very little water in it. So that means the cell that the water would move out of the cell into the environment. And then right here, this is just kind of like what we had on the other thing, just like a little practice for you to do. I just ask you to draw some lines and then see if you can put the arrows on which way the water will move. So there you go. All right, so that is day 2.